Hey guys, so this is a first in a while. Um, I'm going to be doing a recording of me coding real time on a small branch for Snapd, and I'm capturing my screen from my second computer, overlaying some video on top of it, so it looks like there's a person behind all of this. And I think I'm otherwise ready. Let me double check a couple of things. Okay, I think this is good. Okay, we're set. So welcome. Welcome to the first streaming video of live Snap decoding. I'm going to be working on a feature which you can partially see here, um, which essentially is going to explain what happens when you run a Snap application. When you're a developer and you're trying to understand the mechanisms better, and we're trying to understand the flow between several programs that are involved in running your application. This is the command to use. Essentially, it's going to be snap run -- explain, and whatever you used to put there before. So this is an early sketch. I just started playing with this again. I wrote it like a week and a half, or 2 weeks ago, actually, I think. And it's been sitting in the backlog because there were some more important things to work on, but it's back on the table now. So what do we have? So essentially here in the in the right-hand side window, I have a command that essentially runs snap run explain and like a busybox true commands every time some of the code changes on the left-hand side. I'm setting snap reexec to 0 so that my local copy of the snap command is used and not the one from the core or snap, and essentially piping it to a tool that executes the commands every time any of the Go files change. So it's just going to give me like a live feed. And on the left-hand side, I have just my VI, so I can just like write something, and it's going to update relatively quickly. So right now I'm just after the visual flow of it. It's still partial because it doesn't do one more thing which is necessary to understand the whole flow. The things we're seeing are just the snap run part. It doesn't carry through snap confine and snap exec. So I'm gonna do that here. I think this will work. So we'll see. So make hack is a command that essentially is halfway installing Snapd on your system in real time. And it's partial. It's never like fully baked because it's not a full-blown install target. It's just supposed to be convenient. And I think right now it's doing snap confine, the debug build of it, the apartment profile, snap update NS, a bunch of other guys. And it doesn't do snap, but that's fine because we're running it locally. So snap confine was patched as well, but I'm not seeing it picked up here. Let's double check it was patched. So snap confine is just on the side here, and if we go to snap confine.c, we're going to see explain. There's going to be things explaining as well, right? SC explain should be here, and SC explain is all over the whole thing. All right, so why is it not picking up? I'm not sure yet. Okay, so maybe this is a good example of trying to understand what's going on. I mean, snap run explain will help me. So we're exiting snap confine from this location, lib snapd snap confine, and make hack. Okay, make hack is it's one level above. It was in the other terminal. Make hack did put it there, I think. Snap confine, yes. We got the debug build of snap confine sent there. Oh, obviously, well, it hasn't changed because I was not changing any Go code, and this is only triggering on a Go code change. Hey, there we go. All right, so we have a little bit more now. Wow, it's actually more than fits on my screen comfortably now. Let's zoom out a little bit so it's At least fits visually and we can inspect the flow. So one of the things I got as a feedback for this branch was that it's hard to figure out where's the output from the application and what's the new output from Snap Run Explain. So I've added these, scissor-like markers, but they're only in Snap Run for now, and obviously they're gonna have to be in Snap Confine as well. So let's try to do this. There's a similar, like the flow of those applications is pretty similar. They're doing things and they're without forking another process, execing another binary in the chain, and we can splice something like this here. It's going to be fairly, I think, accurate. Okay, this is the C part. Let's make hack again. And let's fake refresh it. I need to make that right-hand side live refresh a little bit better. So, okay, we got the scissors up top, lots of extra output. All of this is the new output. Otherwise, there's just nothing there. And we're executing to snap exec, and that's one more item that we don't see right now because of a partial setup here. So let's change that because that's going to be interesting for the full picture as well. So again, I'm going to just abuse the hack targets a little bit. Snap exec. I'm going to add snap exec. So snap exec is going to be the one from the tree and not the one from the core snap. So this is actually complicated. Oh, I think someone's coming home. That's fine. Someone will handle that. There are other people. The good thing about working from home is that there's lots of people around and there's always something going on. So that's a bad thing, kind of. So snap exec is an interesting binary. I think no one's going to pick. All right, sorry. Okay, so snap exec is an interesting binary because it's essential for executing applications, but it's not actually the one you use. It's not the one coming from your system. It's the one from the core snap or the one from the snapd snap, depending on how exactly your system is set up. Because the general flow is that snap run, which is essentially the user bin snap, executes a bunch of things, then passes the baton over to snap confine, which is still from your system. The snap confine does a lot of namespace setup and starts using the base snap. And then the base snap either is the old core snap, which actually has snap exec bundled already, or it is the new, well, the base snap without snapd in it. So snapd is coming from snapd snap. So snap exec is also in that spot. So we're just gonna have the last binary is gonna be coming from a snap and not from your system. So this is actually somewhat challenging when you're developing because you always have to know this is going on and you have to compensate for it. And it's kind of hairy a little bit, if I can say so. So just a very quick snap exec part of it. So snap exec, I think, where is it? It's in user lib snapd. Okay. So we're just going to get snap exec there. Make hack. So snap exec gets installed. No. Hold on. Snap exec. All right. It's more like it, I think. And I think here as well. No, yep. Anyway, I'm going to send some of these patches later. So make hack will be a little bit better. Okay, so snap exec is here, but if we rerun this, it's not going to pick up. It's not going to get picked up because if you look, it's executing user lib snapd snap exec, but if you look at some of the earlier parts here, reusing this per snap mount namespace. So essentially, the path here no longer represents the same thing on your system while running the application, the snap application. So there is a hacky way to solve that. And we're just going to do this. We're going to bind mount user lib snapd over, I forgot which one I was using. I think it's the core snap, yeah. Because the root file system is coming from snap core current. So essentially the core snap is the base snap for this demo application I'm playing with here. I'm going to overlay this on top of snap core current user lib snapd. So that's a one-off, and let's check out what's going to happen here. Hey, okay, the snap exec line is here. Well, it's not perfect, but it's okay. Good, it's good enough because now essentially we can make hack, and changes to snap exec are also going to be visible here. So let's do one more change here. Where was the snap exec change we placed here? Okay, let's get rid of this guy. Actually, let's take him and carry him over to tab edit snap exec. There's just one file there. One file that matters, and that's it. So we're essentially, that's the whole main. We enable explain mode if necessary, and then we do the hellos, and we do run, and run is gonna do more things. In the end, it's gonna execute either the application, the hook. Where's the hook? Where's the application? Okay, there are two parts of it, two separate code paths. Okay, there we go, executing. And finally it calls exec, the system call. So let's just gonna paste our snippet here, make hack again. I really need to get this better. Let's make it better actually. Let's make it better by making it a little bit smarter. Find name C or name go. So we're just going to get every C or go file, and then we're going to go build. We're going to make hack. And we're going to snap run. Explain, blah, 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 blah. This is not good enough yet because snap make file. Yeah, make hack does not do snap itself. Snap. The snap binary is the multiplexing launcher for everything. So just going to make hack that guy. I think he goes to Bindir. Okay, and last one to go. I mean, this is really low tech. We have a full-blown CI system, but the full-blown CI system is, the latency is high. So essentially, you're going to wait for quite a lot of time to get an iteration done. I'm really looking for something that will let me just, essentially see what's changing essentially in real time. This is good enough. So let's move the Parmer parts as well. Okay. Yeah, snap and -d as well. Okay, I think this is good enough. All right, make hack. Let's see what happens. And let's try this guy now. Oh boy, it's gonna make hack all the time, which is gonna ask me for my password. It's gonna, okay, LLL. It was updated, so we see the scissor snippets up here and down here. And I believe we can now keep on changing things as I want it. And we'll update automatically. Well, yeah, okay, that's good enough. So, is this readable? Ish. I mean, there's tons of information here, partially because that's the point, but partially because that's a very early draft of what this was supposed to do. And even though there's a ton of information, it's not enough because there's way more things that are happening. Well, not way more, but there are some code paths that when exercised would just show nothing new. So the thing I want to ask myself first is it consistent with itself? Like, are we using the same kind of flow, like dashes, colons? Yes, colons for enumerating things here and here. Okay. Dashes here. This is not ordered. I would love to reorder this so it's nicer. Range environments. Oh yeah, this is the wrong one. There are multiple things that can inject environments along the way, essentially. There's snap run, there's snap confine, and lastly, I think there's even snap exec, if I remember correctly, because what will it do? Maybe not. I forgot. Anyway, let's not do it now. Let's not dwell on how and which part injects environment. Let's just solve the ordering. Okay. Keys. Len of what? Env. Okay. Invite range and oh, it's gonna be a little bit dumb. Key value. Let's do this, and finally we know we have the keys, but we need to split them anyway. Well, that's fine. It's just for debugging. Well, actually, we can just sort the whole environment items. Oh. No, sorry. Okay, this is much nicer now. Although, where is env coming from? From here. Oh. What did I do wrong? Sorry, come on. Okay. Maybe this is actually a slice already. Go dev. Okay, it's a slice. That's easy. I don't need to do any of these. All of them can be just sorted this way. Sort package. Right. Okay. Hey, at least they're sorted now. What do we have here? So I guess the same thing can go into snap exec. Although I don't think there's that much there. Sort. We don't do any code sharing between these two places apart from super fundamental things because we're trying to keep them as small and as distinct as possible, and essentially snap exec is super specific. It doesn't usually do much, so I think just copying that line was okay. All right, so what do we have? We have arguments for something fine. We have the environment that was altered. we have snap confine picking up and doing its thing, setting up the device C group, using the mount namespace. Oh, that's interesting. We can actually explore that path. Just double check one thing. Okay, we're at 20 minutes now. Okay, I'm gonna keep this to under 30 minutes because it's a first recording. I just want to see where this goes. So we can make one more thing. Snap discarding this. Okay. All right. So I've changed one item. So every time we run the whole thing here, we're going to get a new mount namespace, and there's going to be some additional output from that. And it's essentially just this creating new per snap mount namespace. And there's some basic pointers. So the whole idea behind this is that it's not the entire dump of everything that happened. We already kind of have that with with various debug options, but it's a more structured and more this is the things you may be interested in kind of flow that goes through essentially the most important things that happen during application startup. But one of those is actually setting up a mount namespace, and that's a big topic in itself. And for that, we're actually going to go to snap update namespace, which is this binary here. And I just wonder if there's something here that we should be logging that is interesting. First of all, let's check if we actually pass this logging into that binary. Maybe before we go there, are we snap update less doing? Are we updating it in Hack? Yes, we are. Okay. Okay, I think we should do some code sharing because it's going to be like a third place where this is going to happen. I think that's enough. I think that's enough already. Okay, let's just steal those for now. And let's see what happens here. It's interesting. There are things that are worth explaining, if I can say so. So one of the things that is special about the snap update NS binary is that it runs with a large C preamble that is doing system specific setup, well, not systems, like OS level setup that is hard to do from Go. Let's just do it like that. Okay, now we're getting somewhere. Let's see. And I think that's actually interesting and worth explaining. So let's just quickly steal a little bit more so enough is initialized. If there is, are we importing OSUL here? No. Okay. Okay, and snap explain. So let's do this. Snap explain. Okay. Snap update namespace. Let's just see if it gets picked up. It's not being picked up, and I think the reason for that is because when snap confine, when snap confine is running snap update namespace, it is doing that with a very specific environment. And essentially, it's an empty environment to avoid leaking all kinds of stuff. Oh, sorry. Tool support. Okay, I think I found what I was looking for. And we don't even tell it, right? That's the thing. We don't even tell it about snap explain. So there's going to be one more. Snap explain equals x, And let's see how that plays. Yeah, there's a lot of complexity between all these different programs interacting and being privileged, because it becomes root even though the invoking user is not. So there's a lot of paranoia to make it safe, or at least not to make it safe, because that's kind of like we can't make it safe, but at least to make it less prone to attacks. Hold on, I'm just jumping blind across those things. Okay, one more thing here. Snap explain, snap explain. Well, it's just gonna. If there's anything in getenv, then we're just gonna get it. Okay. One more thing, snap discard on this. That's another item that is worth explaining. Oh, sorry, snap explain. I didn't sleep all tonight. Last night. Okay, one more thing. Where is it? Where is it? Snap explain it here. I think that's all of them. Okay. And we've got nothing. Let's check out how we're actually invoking these things. Do we have any IO redirection done that kill them? Like to kill the output? I don't think we do. So this is C, this is go, and right. So we can try. Yeah, I think I should rearrange some of the helpers right now because I just don't have access to them in the right spot. And that's gonna be annoying now. Let's do it. There's like a utils package, which is random stuff. I think it is sensible to put the explain parts here. Where is SC explain coming from? Oh, it's already here. Oh, it's good. Huh. Okay. Yes, SC explain is here. That's excellent. We have a helper. Wow. Okay. I can make this lousy job up here. Okay. This was not what I wanted to do. Was it SCS explain enabled? We may actually get some output this time. Except we didn't, obviously. All right, one more of those. Hey, now we're looking at stuff. Good. Okay, that's interesting. So we have, I'm gonna go do like unit tests and stuff later. Right now we have the part I was interested in. So we have snap update NS in this flow, and I forgot which part did this. It's in snap confined C. Okay, let's just here then. So now we have this. If you look at the flow, we're in snap confine, we're in snap confine, now we're in snap update NS, and now we're back in snap confine, and that's a little bit tricky for the output. I wonder how to structure this so it's more readable. So it's something people can actually follow. Come on. Maybe as simple as that. Yeah, I think that's gonna be nicer. Well, I'm not sure about returning to part, but yeah. Okay, so we have snap confine, we have snap update namespace, and what else can we talk about here? There's this bootstrap part I've mentioned, bootstrap C, and this is another part of C code that essentially shares nothing with anything else because it's super tricky to get right because it is before most of libc is operational. It's pretty annoying to work with. Like we can't even use, I think we can't even use is printable or something like from the libc because that requires a working relocation of some table, and that's too early for this code. So what happens here is that there is a set NS call. And I think that would be nice to talk about here. Set NS into snap. And yeah, it's doing this. So let's try it. If we can, updates, go away, updates. Not now. Huh. Yeah, it's always better to have a new line. But still no. That's interesting. Huh. Oh, right. So we did not switch into a snap namespace. Snap on namespace because essentially we've been discarding it all the time. And if we go out for a second, we can, sorry, we can just introduce like a typo here. So it's going to be like toolbelt-2. And now it's creating new, no, up here, where is it? Reused per snap mount namespace. That's good. And we did not run snap update namespace. Oh, right, because snap update namespace is not invoked if the mount namespace is, well, up to date. So maybe there's nothing to add here. I don't know. Yeah, it's only going to be picked up if snap update NS is invoked by snapd, and then this will join the existing mount namespace to do the updates. So I think there's nothing interesting, at least immediately, to log here. Let's see, what can we log here? There's a lot of things we can log here. First of all, let's actually keep recreating those namespaces so we see interesting live updates. Yeah, actually we can talk about the mounts we're doing. I think that's the most interesting thing that's gonna be happening in this entire program. Like everything else is just support so that at the end of the day we can do some system calls. Where was it? Low level thing here. Yeah, I think this is the part that is interesting. Like, this is where the meat happens. Let's try this. Mounted something. What was it that we're mounting? C entry. Let's see. I think this is not going to have many mounts. Yeah, there's not. It's a bad sample program I picked. But we can be a little bit more creative. We can just create a mount profile for it. var lib snapd. Actually, let's do it on this side so I don't interfere with the video and with the rest of the flow. var lib snapd mount profiles, and there is like a mount profile for every snap that has one. Test, what was it now? Snapd tool belt fstab, and these look like essentially like fstab files. So I can say like, what was it? Let's see fstab. I forgot what the syntax is. All right. So the device name, like I'm gonna say tempfs. Mount point, I'm going to say opt. I think there's opt in the core snap. Type of file system, so tempfs. Mount flags, default. Options like 0, 0. And there's something I can add here as well. X, snapd, origin, layout. I think it's just going to be enough for this guy, and sorry, here let's force it to say something. All right, it's interesting. So snapd is very security minded, and even the act of starting application from command line is heavily confined. So there are precise permissions modeling exactly what the snap ought to do, including what the support tools ought to do for that snap. So yeah, we got permission denied, but at least we said like we got this part, so that's interesting. We've been mounting things. So I think like trying to fake it was the bad idea, but let's get rid of it. But actually trying to, I'll just use a better snap. Okay, let's check the time. It's 38 minutes. I think this is getting too long. Okay, this is the first one of, I'm not sure if there's going to be many more. We'll see. There's going to be some more, I hope, of like live coding videos. It was very chaotic because it's just as chaotic as I am, plus all the extra things that recording a video is making me do. And I was just showing a bunch of things that, you know, that go into developing snapd. I'm gonna see how it looks like after cutting. Maybe I may remove some things, but other than that, I'd like for the live videos, I'd like to have them as unedited as possible, so they're not annoying to work with every day. Let me know if you liked it or if you didn't like it. If there's something specific you'd like me to see record, or just give me a thumbs up if you liked it enough for that. See you next time, and bye-bye.